Hello and welcome to the third lecture of the Smart Cities course. This lecture will bring an example of a really advanced technology. We'll consider main benefits of AI-driven technology, challenges, and open questions. Our homes are getting more and more advanced, more and more intelligent. It means that they are not just a place for living. They not only consume energy, but they also start producing energy. For example, using solar panels, consumption of energy is also not easily predictable. Some buildings can integrate quite large consumers of energy, like charging electric vehicles, etc. Moreover, the buildings are interconnected into a larger infrastructure, into so-called smart cities, where they are capable of learning from each other, capable of exchanging information. But all this technology opens new challenges. One of these challenges is balancing the electric grid. What does it mean, balancing? It means that energy, here we talk about electric energy, so this is a really specific product. As we produce it, it has to be consumed. It should be a balance between production and demand of energy. Of course, some amount of energy can be stored, for example, in batteries, but the storages are really limited. The amount of energy that we can store is really limited. So, what will happen if we start consuming more energy than it is produced? In fact, it can happen in practice, but as the result, the frequency will drop. We will not have 50 Hz in the grid anymore, but it will be lower, and it can cause problems for the grid, problems for electric devices, and so on. Thus, every second we have to keep the balance. Let's now consider the situation when the demand is more than production. What will happen in this case? So, if the demand is higher than production, it influences the frequency, and we have to react to the situation immediately. What can be done? One solution is quite obvious. We need to produce more energy, but it's not so easy, because running the power stations requires some time. Running new additional stations, it's a quite expensive and slow process. Instead of producing more energy, we can reduce demand, we can reduce the consumption. So we can make actions on the demand side. And this is what is called demand response or flexibility. Flexibility in this context means possibility to react to the situation in the electric grid, immediately reduce energy consumption. As we talked in the beginning of this course, buildings are the largest consumers in the grid. Thus, they provide the highest potential here. But inside one building, we cannot provide so much energy in order to balance the grid. Or otherwise we need just to turn off everything and it ruins the comfort. But we can take many buildings. We have smart cities. We have a number of interconnected buildings, and we can make adjustments, just a little adjustments in each building. For example, we reduce consumption of energy by just some small percentage, 5% in each building. For example, for 15 minutes, ventilation will work with 10, 20, 30% less power, and nobody will feel it. But when aggregating it together in the whole city, it can provide significant influence on the grid, and it can correct the situation, and by doing so we can balance the grid. Absolutely, the same situation can happen when energy production is larger than demand, and happens. It happens really, for example, in windy, sunny summer days, when production of PV panels is high, production of wind turbines is high. We have a lot of energy, but we don't need so many energy. So in that case, we can increase the consumption of energy. And this market where we can sell our flexibility is called flexibility market. There, if we are ready to react within some minutes, we can offer our amounts of energy. It doesn't mean that we produce 1 or 2 megawatts energy. It means that we are capable of quickly reacting. In some minutes we are ready to increase or decrease our consumption, and in this case the clients, the consumers of energy, are getting paid. They are getting paid additional fee for reducing their consumption, or they are also paid for increasing the consumption, but doing it quickly and in the right moment. So the buildings can serve as huge batteries that can be used to balance the grid. And if your building is flexible, you can earn additional money by reacting, not just paying for consuming energy, but you can earn money by providing flexibility to the grid. AI-driven solutions in buildings have obvious benefits. First of all, they work 24/7. They can analyze huge amounts of data, so-called big data. They can model and predict buildings' dynamics, optimize consumption based on day-ahead forecasts. They take into account energy prices. Also, buildings can exchange information, and they can learn from each other. They can learn best practices. We can apply cloud or remote solutions without necessity to use or install additional hardware. In most contemporary buildings, already all the necessary hardware exists. They're already equipped with sensors, actuators, and so on. We only need to add smartness to the building, intelligence. By using intelligent solutions, we can synchronize all the subcomponents. They will not work separately from each other, but they will make decisions together, and it can significantly improve energy performance. Also, we can make a lot of micro adjustments. We can do them several times per hour. That is not feasible for a human, but it's feasible for a technical system. As the result, we can reduce energy demand by 15 to 30%, and as the result, we also reduce CO2 emissions. At the same time, we have a number of challenges that we need to address. First of all, it's explainability. Most of AI and machine learning based models are so-called black box or gray box models, so sometimes we don't know why one or another decision have been made. And it's necessary to add this explainability to understand and make the systems more trustworthy and reliable. Also, because of using AI, systems are getting more complex. As the result, we have to pay for computations. So computational costs are increasing. One of the challenges is definitely quality, amount, and availability of data. In relation to the first point here, trustworthiness, safety, reliability have to be provided by adding explainability. And also, we have to take care about stability of the systems. We need to guarantee the stability of systems that are making any decisions. Thank you for your attention, and now you can test your knowledge by answering questions.